as we can see here for number 1, the listen to audio, we can see that the sound, if my, let's just start working. Oh yeah, if we can see that the sound, if frequency gets high, the tone gets high. If the frequency gets low, it gets lower. The sound that gets lower. However, if the amplitude gets higher, the sound gets higher. If it gets low, it's like it's a speaker. Speaker really. And for number 2, that's something about the vibrates. So it vibrates back and forth. As we can see from the character, we can see that. Oh wait, we have to go to listener. We can see that the sound is far away, but when we go closer, it's actually there. Pause this. And if we go measure, I already measured this a while ago. I got, for one wavelength from 0 to 2 meters, I got 0.0056, and I did the calculations, in which wave speed is the formula for wave speed is wavelength over period, or lambda over t, which is 2 meters divided by 0.0056, which is almost close to 357. There's another formula for this, or you can just do formula where we can find lambda times frequency, and yeah, that's how we find the frequency. And the frequency is since the time is 0.0056, it's gonna be what the frequency has to be the tenth, hundreds, thousandths of a thousandth of 56 for frequency, the frequency of the wave in this time period for 500 hertz. Okay, so I just basically answered 1, 2, and 3, and I think 4 too. And number 4 is the wavelength. The wavelength is like basically the distance from measured in propagation for a wave. It's like different sounds. Different sounds with different. So we can see that we're getting this one. I would answer 1, 2, and 3. I don't know, my screencast thingy turned off, so I'm not sure where I went off. But for number 4, I got that number 4 is the wavelength, where the wavelength is basically the distance measured in propagation of a wave, and we can see right here too. So if we go to number 5, so that's basically the wavelength, where we change like different sizes here. And then if we go to number 5, the simulation tools, it's asking you the simulations to do the period wave and speed of sound. How do when you found it? But that's what I did a while ago. That's the speed of sound. The speed of sound is 340, where you divide lambda over t. Excuse me. Number 6 is a period of a wave or frequency. All we have to do is just since we're trying to find the period of a wave using the frequency, we could do f equals to 1 over t, or t equals 1 over t. So it really depends upon the situation. For this problem, it's asking us to do t equals 1 over f, which in this little thing it doesn't show me. But yeah, so that one relates back to number 5, because we're trying to find the wavelength, and goes back and forth. Number 7 is describe how you would find the frequency of a wave if the frequency side did not have number display. So if this one was gone, this frequency number is gone, how do we find it? Well, we could find the frequency, we could use numbers, or so basically what do we have to find for number 7? And for number 7, we just have to find, like, t equals 1 over t. It's asking you for the frequency of a slider, and the frequency of a slider is just asking us, hey, is it 0.0? If we're losing this one, what do we have to do? So what we have to do is have different sets. So what I got was divide over speed over sound and over wavelength. So divide the speed of sound, which is basically 340.29 divided by the period, and you find basically the wavelength for that. Or we could do t equals 1 over f, where we find the f frequency, or f equals 1 over t, or even better, we could just use the frequency thingy, like the one frequency and the numbers, just divide them. That's it. So yeah, that's it.